Hello everyone, I am Dr. VRAO from the lectures 61 and 62 of thermodynamics. We came to know that it is impossible to construct a perpetual motion machine of second kind. I repeat, it is impossible to construct perpetual motion machine of second kind, and it is the statement of second law of thermodynamics. And moreover, this second law of thermodynamics introduces a new state function, that is entropy. Entropy is a measure of unavailable energy, right? And mathematical statement for entropy is given that ds is equal to dq reversible by t for reversible processes, and ds greater than dq reversible by t for irreversible processes. Right? So, these are the mathematical statements of entropy. That is, entropy ds is equal to dq reversible by t for the reversible processes, and ds is greater than the dq reversible by t for irreversible process, which means that in reversible process, entropy of a system and surroundings taken together that remains constant. I repeat, which means that this mathematical statements means that in reversible process, entropy of the system and surroundings taken together, entropy of the system and surroundings taken together, that equal to that is remains constant. And for in irreversible process, entropy of the system and surroundings taken together, entropy increases, right? So, for reversible processes, entropy is equal to dq reversible by t, that is, that remains constant. For irreversible processes, dq is greater than dq reversible by t, that is, entropy of the system increases. ds is greater than dq reversible by t, that means that entropy of the system increases. And moreover, an irreversible process is spontaneous process. From the previous lectures, we came to know that irreversible process is a spontaneous process. Therefore, during spontaneous process, entropy of the system goes on increasing. I repeat, during spontaneous process, entropy of the system goes on increasing. When the system reaches equilibrium state, entropy of the system reaches maximum, and there is no further increase in entropy of this system is possible. I repeat, for spontaneous process, that is, in spontaneous process, entropy of the system goes on increasing. When the system reaches equilibrium state, its entropy becomes maximum, and there is no increase in entropy of the system is possible. That is, which means that for any system to achieve equilibrium state is that is condition for any that is condition for any system to achieve equilibrium state is that its entropy becomes maximum and there is no entropy change is 0, and entropy change is 0, right. Delta S is equal to 0. That is, you should keep one thing in your mind, that any system, or the condition for any system to reach, to achieve equilibrium state is that its entropy becomes maximum, and change in entropy is 0. This is the condition for equilibrium state. Okay, you remember a simple bold statement, condition for any system to achieve equilibrium state is that its entropy becomes maximum and change in entropy is 0, right. So this is the very important condition, and based on this condition we can we can conclude that spontaneity, statement, that is, we can conclude the spontaneity, condition for spontaneity. And now we calculate the entropy changes in a reversible process, isothermal process. Okay, now let us calculate entropy changes in reversible processes. From the definition, that is, for reversible processes, ds is equal to dq reversible by t. Already I told you why this reversible process. Already from the, if you want to know the reason why we are writing reversible here, you go for previous lectures, right. So from the definition, for reversible processes, entropy change ds is equal to dq reversible by t. Okay, and we can write this as TDS is equal to dq reversible, right, dq reversible. And from the first law of thermodynamics, dq is equal to delta u minus dw. Okay, this is from first law of thermodynamics. Du is equal to q plus w. This is first law of thermodynamics. From this we can write dq is equal to du plus minus dw. Okay, and du is equal to delta u is equal to from heat capacities, delta u is equal to NCV dt. For n moles of substance, we can write that delta V is equal to NCV dt. And dW, we are already, I told you in the previous lectures, dW is equal to work is equal to minus PdV, and here this is minus dW, work done by the system. Therefore we can write PdV. Now NCV dt plus from the ideal gas equation, PV equal to nRT. From this P is equal to, we can write nRT by V. So therefore instead of P we can write nRT by V dV, right. And in the next step TDS is equal to, and in the next step DS is equal to NCV dt by T plus NR TT get cancelled, NR dV by V. Okay, on integration with the appropriate limits, this equation takes the form ds is equal to ncv ln t2 by t1 plus n or ln v2 by v1. Okay, this equation takes this form by integration between with appropriate limits. ds is equal to ncv ln t2 by t1 plus nr ln v2 by v1, and in terms of CPs, this equation can write as ds is equal to ncp ln t2 by t1 plus n or ln p1 by p2, because v and p are inversely proportional. Okay, so this is the equation for calculating entropy change in reversible process. Therefore, ds is equal to ncv ln t2 by t1 plus n or ln v2 by v1, and ds is equal to ncp ln t2 by t1 plus nr ln p1 by p2. So, this is about entropy as a function of t and v. Okay, this is the equation in terms of entropy in terms of t and v. T and v, entropy change in terms of temperature, volume, and this is entropy change in terms of T and V, P, T and P, right. So, these are the equations, these two equations allow us to calculate entropy change in reversible process, provided if T and V are given, we use this equation. If T and P are given, we can use this equation. Now, let us calculate entropy change in isothermal process. Now, let us calculate entropy change in isothermal process. In already I told you in the previous lectures, in isothermal process, Q and W take opposite signs. Q and W takes opposite signs. For example, in this is Q and W takes opposite signs in isothermal process. How can why these two takes opposite signs? Because from the first law of thermodynamics, delta U is equal to Q plus W. Q plus W. In isothermal process, temperature remains constant. When temperature remains constant, delta U is equal to 0. Delta U is equal to 0, then Q plus W is equal to 0, then Q is equal to minus W. Okay. In this way, the Q and W takes opposite signs in isothermal process, right. And now, let us calculate entropy change in isothermal process. We know the equation ds is equal to dq reversible by T. Okay, this is the equation which allows us to calculate entropy change, right. And in isothermal process, work done already I derived this equation in the previous very first lectures of thermodynamics. W, work done, and the formula to calculate work done in isothermal process is minus 2.303 nRT log V2 by V1. This is the equation for work done in isothermal process. W is equal to minus 2.303 nRT log V2 by V1. Okay, but in isothermal process, Q and W takes opposite signs. Therefore, we can write ds, delta S is equal to dq reversible. Dq reversible means here we can write the opposite sign for this equation, that is 2.303 nRT log V2 by V1 by T, right. This the T get cancelled, then the equation 2.303 n or log V2 by V1. So, this is the equation for entropy change in isothermal process. Okay, so in this way we can calculate entropy change in isochoric process, isobaric process, right? So this is the way to calculate entropy change in remaining processes, that is isochoric process, isobaric process, right? I hope you learned something, and if you learned something, you please extend your support by like, share, comment and subscribe. Thank you. Thank you for watching.